Alright guys, got a bit more done on the Rockford planer. I've got the main part of the, I guess you call that the compound or the downfeed slide installed. Quite a trick to get those 4 studs lined up and the center hub lined up to get everything put back in there. But I kind of had it in my lap and manipulated it with my fingers and got it all situated. So that's cool. Let me show you a little bit of there's the top locking screw, and it had a grease fitting in there, and I of course blew out the grease and changed that to a real oil cup, so that's gonna work nicely. Also, I did the same here. That's a Gitz cup for the bottom ways. That used to be a greased Zerk as well, and I showed you guys in the last shot there. It went to the middle, that allowed, you know, the gears, the trunnion for the gears and all that. So now that's all blown out. Quite a bit of grease came out of there. I got an 1/8 inch pipe street L in there, and I happen to have, I'm not sure if I like the I didn't want it this long, that all the way up to the top, but I'm going to stand back. The level of that has to be higher than the center, a little bit higher than the center, because the oil hole's at the top. So it's about 2 inches higher than it needs to be, but I don't mind it. I don't mind the height of it. I don't know if I like the function, the form of it rather, but it doesn't hit. This is a stop block, and it comes in just behind that. So, and none of this piping hits any of these Gitz cups for the side feed gearbox. So you can run it back over without any issues. So that's, and I cleaned a whole bunch more grease and everything. So I'm kind of standing on my chair here. So that's been replaced, a grease fitting with an oil cup. That's been replaced, the grease fitting with the oil cup, and these two were also grease fittings that I replaced with oil cups. And the manual had those as oil cups, so kind of interesting. Let me kind of step down. So when you turn the crank, you can kind of see the gears moving, and maybe you can see the shaft rotating. There's a keyway right there. See, keyway. This whole works. So I guess this is the feed works for the top, for the down feed. This is for the cross feed, you know, and you can see the whole lead screws turning, coming towards you. So that's for that, and of course this is left right for either one. So I don't know if you engage that and that, if it runs at a 45 degrees, I don't know. Kind of interesting to see. That's it so far. Let me put some more parts on it, and we'll see how she goes. Alright guys, I got the top slide put back on. No drama, no issues. There's a thrust bearing below and a thrust bearing on top, and the next thing to go on is the dial and the retainer collar, and of course the crank. And for you guys, there is the lock that tightens the gib, and kind of see the back of the whole works. So that's that. I want to show you guys this stuff. I call this Lucas Motor Honey. STP, or scientifically treated petroleum, is the same thing basically. Oil stabilizer, I guess Lucas oil stabilizer. But it's thick like honey. It's really, it's absolutely like honey. So I slathered that all over the gib and the ways, the dovetails, and of course my regular whey oil. So let me do some more work and I'll show you the progress. Alright guys, I wanted to show you the threaded hub assembly that the dial part of the compound goes on. I got it set up in the milling machine. And this is the thing I had to heat up with the torch red a couple times before I realized it was threaded on the inside. But I got it off without any damage. I looked at the drawing in the manual and it showed threads. So anyhow, I got it in the mill. I'm going to mill some wrench flats on it because there's no good way to get a hold of it. You can see they put the part number on it. That's an oil hole. And I got this long Allen screw in the set screw hole. Now there's a brass pad inside which bears on the threads. So that secures the whole works. And trying to get the lighting right. I just stuck a parallel to get it straight. That's all that's for, is to get the wrench flats I'm going to mill parallel to something, and that would be the screw hole that you tighten to lock the threads. And as you can see, the oil hole is a bit off. Doesn't matter, that's just how they made it. One thing I wanted to draw your attention to is I got it in a very small V-block. And I want to show you, now that's the proper way to hold something, and actually you might be able to see I got the V-block on parallel. So the parallel keeps the V-block square, which is resting under the hub. There's actually a hub on that, and that's what's keeping it flat in the vise. But what I really wanted to, so this is my collection of a couple of these machinist-made V-blocks. And there's some story to these. I found these on the ground in the dirt in a scrapyard, in a junkyard. Now, this was Steel City, steel recycling yard on South Park Avenue in Buffalo, New York, right across from Sorrento Cheese, next to Recchio's Bowling Alley. I don't know if these places are still around because it's like over 10 years ago. But I used to work for Moog in East Aurora, New York, Elma, New York. And, but anyhow, Bill Moog invented the servo valve, hydraulic proportional flow control valve. And they're into aerospace stuff and a bit of everything. But Moog is a very prestigious place to work. And I actually worked there as an electrician for a while out of college. But anyhow, these V-blocks were made by somebody at Moog. The name Moog is on them. There's a couple other tool items I picked up on the ground in the junkyard. And it had Moog written on other items, indicators, snugs, and just pieces, parts, and whatever. So Moog had a really cool model shop. They had a building. It's like a six-sided building. It wasn't a Pentagon. It was six-sided. Anyhow, that's what the model shop was, and the precision machinery, you know, like Harding stuff, Moore stuff, Pratt Whitney stuff. Anyhow, somebody's toolbox just got tossed at this scrapyard, and these were in the dirt. So some of them got some more things engraved on them, sizes and yada yada. Some are 120 degrees, some are 90, some are 60. So like, I think the clone of this one, no, that's actually a 120 degree block. But anyways, you just never know. Having worked at Moog, and it's just, you know, I think it's called Moog Aerospace, and there's Moog Defense and whatever. They make motors, electric motors. But anyhow, pretty happy to have these because they were on the ground in the junkyard. And I used to ride motorcycles with a guy, Skip, and his brother's girlfriend or old lady owned the junkyard. So it was sort of a friend of mine that I knew the guy that owned the place, and they'd let me walk around. But point being is these are real handy for all kinds of stuff in, you know, a milling machine vise. Now, let me take you, so I keep them here, but so your normal next smallest one is like that size, and that's too big for using in the vise typically. Sometimes, just depends on what it is. But you can see Brown & Sharps, some imported Encos that I reground and up and up and up, and this is like a bigger one, and then magnetic ones, and I got like absolutely huge ones in the cabinet over the other way there. So these are kind of tooling parallels, and this is cool. These things have so many holes in them. They're light as can be. You wouldn't figure, I mean, I swear this is aluminum, it's so light because somebody drilled so many holes in them. And I got 3, you know, identical one of these. So it's just neat. I mean, these are, I forget where I got these, I think eBay. But somebody made these, and they're exactly, you know, 1, 2, 3 by a good many decimal points there. But anyhow, I'm getting off topic. I love tools. I bought some parallels at an estate sale, and you know, really awesome. But just wanted to show you those V-blocks because, you know, these are just kind of, you know, actually too small. Yeah, these two, this is a pair. Does this say Enco? No. Yeah, you probably can't see it, but these are Enco, and I reground them because they were, yeah, not so good. I mean, they weren't bad, but whatever. Okay, as you can see, I could talk about tools for absolutely forever. Let me get going on this over here, and put these away, and get going on this dude. Pretty good. Let me do the same on the opposite side for the other flat, and you know, I'll bring you back. All right, guys. Here is the finished result. Man, I'm no Vanna White when it comes to the camera presentation here. what it looks like. So that's 1 3/8 across the flats, so you can get a wrench on it because it's internally threaded. So you can tighten it and loosen it and take it off, take it apart, put it together. There you go. So should be nice. I'm going to deburr it with a stone. And I surface ground the top before. You can see the crisscross pattern. I kept rotating it while it was on the magnet. Just trued it up a bit because it was a bit out of flatness. So let me get you going here, stone it up, deburr it, and put it together. All right, Doozer here. I got the dial nut, the dial retainer, the piece I was working on. I got those flats cut over in the Clausing 8520 milling machine, and I don't think I explained maybe why I was doing that. So let me show it to you in place. I got it up on the Rockford planer, and let me show you how it looks, how it fits, and it's all back together. So let me take your handheld. Let me step up here. All right. So what we got, you can see everything bolted back together there. And we got that flat milled on there, right? And let me zoom back a little bit. Look the other side. There's the other one, right? You can see there's the oil hole at 3 o'clock there, and kind of see how it works. But the reason that I put those on there is because, like I said, this is actually threaded, right? On this goes on the lead screw, screws on to the end of the lead screw. And I'm turning this over here, right? That's all connected with the gears and whatnot. So that's kind of cool. Yeah, the reason is that this is actually a nut. And when I was taking it off, I didn't realize that it was threaded. I mean, it's a collar. It's a threaded collar, right? And it houses the graduated wheel, right? So that is a collar that's threaded. And because there was no identification that was retained by threads, it was confusing me. I thought it was just keyed on there, or slipped on, clearance fit, whatever. But the reason I added the flats, of course, as I said, is it is threaded, and it is technically it's like a nut. But this is an example of design language, okay? So because there was no physical features to indicate that could have wrench torque applied, right? There was no flats. The design language didn't tell me that it was a nut or a female threaded hub, or whatever you want to call it. So that's why I did it. Now that I know that it's threaded, I know, and the only reason I knew is from looking at the drawing, because there's no threads visible on top there, because the handle, even with the handle off, there's no threads visible. So threads visible would have been part of the design language that cued the person working on it, using it, that it was a nut or threaded collar or whatever you want to call it. That's a design language. So I incorporated these flats, these features, to tell a story to whoever is using this and interacting with this, that's how it comes off. It is in fact a threaded hub, a nut, whatever you guys want to call it. So that's all I wanted to talk about real quick, is the concept of design language and kind of why I did this. So now it's easy to put a wrench on there, tighten it up, take it apart. No fussing around in the future with it all. So yeah, that's important. When you're designing things, have a cohesive language to your design that tells a story about how to interact with the parts, the component, the assembly. All right, thought I'd share that with you guys.